Okay, let's look at how to do some math in LabVIEW. We'll look at two different ways of doing it. Um, so here's a piece of two equations. These are just screen captured. This isn't. This is just a bitmap image copied onto my block diagram to look at. So I'm going to calculate a variable called S1, and it's calculated from three other variables: x and y and t. And this is the equation we're going to use for S1. S2 is almost the same thing, only it's a subtraction here instead of an addition. So we want to look at how to do this. Well, we need numeric controls for x and y and t. So I'll come over here and put some numeric controls on. I could just use the basic control, but maybe it'll be a little fancy, and we'll put on one of the slide ones. So we'll call this x, and maybe I'll show the digital display as well. I'll move the digital display to the bottom, and maybe I'll make it go to from 0 to 100. And I can adjust this value with the slider, and that's pretty good. So I'll make two more just like it. I'll drag a copy of this and rename it y, and one more to be called t, and line them all up. And I'm going to need an indicator. I'll use something similar for an indicator, so it looks kind of the same, only I'll call it S1. And notice it's still a control, so I'm going to change it. I'll right click on it and change it to an indicator. And maybe I'll change this slide color just for the sake of it, so that it's red and it looks different than the controls. So I've got x, y, and t, and of course they've shown up over here on the diagram. I'm going to maximize the diagram now to see it a little bit better, to fit all this big math in. So to do math with the ordinary function nodes, let me see, I'm going to need an addition and subtraction and division signs and square roots and squares and a bunch of math symbols. So I'm going to go and get them. And you have to sort of do this in steps. I need to take x and y, and I first need to add them and then divide them by 2. So the first part of it, adding x and y, I'll go to the numeric panel and get an addition. And I'm also going to need a division. And I can wire this first part up. So here's x and y added together, divided by, it needs to be divided by 2. I don't need a control for 2, it's always 2. So I just need a constant here. So I'll just right click on this indicator and create the constant and make it 2. I'll move it around a bit. So coming out of this division sign is x plus y over 2. To that, I have to add this stuff. So I'm going to need an addition. I'll go and get the addition. In fact, I could go into the numeric palette to get another addition sign, but I've already got one. Here's one. I'll just copy drag that over and wire up this part of it. So here's x plus y over 2, this part, added to, well, now I need to take the square root of some stuff, so I'll put a square root sign on. In here somewhere, there it is. And it's the square root of, well, t squared plus x minus y over 2 all squared. Okay, so I need a t squared. Here's t. I need to square it. There is a command to just square a number. So here's t squared. And I need to add. Grab a copy of the add and wire that up. And I'm adding t squared to x minus y over 2 squared. Okay. Well, that's kind of similar to this. It's x minus y. I need a subtraction. And you can see it's starting to get confusing and complicated. The order is very strange. I need x minus y. So I'll just click on this wire. And there's x minus y divided by 2. So I'll just grab this and copy drag it down. So here's x plus y over 2 coming out, and it needs to be squared as well. I've already got it squared, so I'll copy drag that over and wire it up. And that's x minus y over 2 squared. What's coming out here is this. That needs to be added to the t squared. So this needs to come down to here. Maybe I'll move this over so that everything kind of moves forward at least. And I have to take the square root of it, which is here. And finally take this whole thing and wire it into the indicator S1. And you go, wow, that's a very complicated looking piece of programming. And this really doesn't look like this. It's hard to glance at this and see that it's the LabVIEW version of this first equation. It is, and it'll work. But it's a little difficult to debug, it's a little hard to create, it's easy enough to screw up, and it does require a strange way of thinking about math. If we go back here, we can run this and it should work. We take our x values and y values and change them, and maybe I'll make this go bigger. So all three of these, they do their thing. I adjust x, y, and t, and I get my S1. And you can follow the calculation as it runs. And see how it works. Notice it's very difficult to predict which of these operations happens first, but it doesn't actually matter. For instance, this addition sign, does it get the top number first or the bottom number first? We don't know, and it doesn't really matter. That's how data flow programming works. Anyway, that's one way to do it. Oh, by the way, this is a bit of a mess. Control U cleans up the diagram. If you hit Control U, it automatically arranges things in a reasonably compact and fairly neat way on the diagram. So this is one way to do math. But when you have math as an equation that's a little bit complicated, like this one, there's another way to do it, and that's what we're going to look at next. I'll move this over. Just rearrange things on my screen a bit. So I need to calculate S2 as well. S2 is also calculated from x and y and t. That's all you need to know. It's very much the same as this, only this would be a subtraction instead of an addition. But instead of repeating this, I'm going to do it a different way. I'm going to go into the program palette and get something called a MathScript node. This is the first one of our programming structures we're going to look at. I'm going to copy this, and I draw and I create this box. This blue box is called the MathScript node. And essentially what you can do in here is you create inputs and outputs on it, and inside the box you just type the math. So that's what I'm going to do. So what's coming out of this is S2, and what's going in is x, y, and t. So maybe what I'll start with is just putting the equation in. So I need the text editing tool, and I can just type the equation in here, kind of like normal math that you would do in Excel or various other computer programs. So S2 equals, and let me see, in brackets, it's x plus y, close bracket, over 2, plus the square root of some stuff, the square root of t squared, t to the power of 2, plus, in brackets, x minus y over 2, and then that in brackets squared I gotta get rid of these extra spaces. You can't have extra spaces in LabVIEW. And this corresponds to this, and the square root of t squared. Sorry, this should be a subtraction here, shouldn't it? Square root of t squared plus x minus y over 2 squared. Pretty easy to screw up the brackets here. Let me see. That bracket matches that bracket. That one matches that one. Got one too many brackets here, I think. So this is the usual problem we sort of come across here. So another way to do this is we could think of this expression S2 is equal to being something minus something. And we could think of these two things as sub-expressions. I can think of this as expression 1 and this is expression 2. So I could start off by defining expression 1 is just, in brackets, x plus y over 2. That's this part. And expression 2 is the square root of, in the brackets, t squared plus something squared. And that something squared is something over 2, and this something is x minus y over 2. So I've defined expression 1 and expression 2, and I can just now define S2 as expression 1 minus expression 2. I have to hook these up now. So I've got some code in this box that should work, except that x and y and t haven't been defined. So what I do is I right click on the frame on the left hand side and I choose to add an input for x and add an input again for y and add an input again for t and wire them up. The little x's here have disappeared now. We have red x's here indicating that the equations didn't work because x and y and t hadn't been defined, but now they are. Now I just need over here to add an output and add S2 as the output, and I'm going to need an indicator for S2. I'll tile the screen and I'll just drag copy an indicator and rename it S2. And wire that up. You can see that my program is runnable. I can run it. And now I have my S1 and S2. This needs to go to negative numbers. And they both work. If I maximize the diagram and watch it running. So this MathScript node does this equation, and this pile of math nodes and math functions does this equation. They both do kind of the same thing, but this is a little bit easier to deal with for larger equations. And I hope that helps.